Okay, here we go. So we've talked about simplifying radicals in our last unit, but now we're going to be solving radical equations. So basically you're solving for x, but the equations you'll notice have a radical in them. So there's an example up here. The first step is to isolate the radical. So you're getting this part by itself, so I did that by adding 4 to both sides and then dividing both sides by 5. And the radical is by itself. So that's your first step. Then the inverse operation of cube root is to cube. So here's your cube root. You're going to cube both sides. And you'll notice that that cancels out your cube root. And you get 2x equals 8, and then you solve it. Now, solving with a cube will not give you an extraneous solution. But solving with a square could give you an extraneous solution sometimes. So in general, we just always check. We check our solution by putting it back in to make sure it works. And it did work, right? It worked. So that means that this is my solution.
This one is extraneous.
Good question. So an extraneous solution means that you did all your steps correctly. However, when you substitute it back in, it doesn't make the equation true. So it's not really a solution, okay? The reason why you can get that with squaring in square roots is because when you square a positive number, you get a positive, but when you square a negative number, you get a positive. This is the thing that can lead you to getting these extraneous solutions. It doesn't happen with cubes, but we still just as a matter of course, we just always check our solutions. So we're gonna do problem, should we start with problem 1? No, let's do problem 3 together, and then I can give you a minute to try 1 and 2, okay? So looking at problem 3, I have to get my radical by itself, so I'm gonna start by getting rid of the minus 3 with a plus 3 on both sides. Okay, so I have negative 6 square root x plus 4 equals, add that on your calculator or in your brain, negative 12. Then I'm going to divide both sides by negative 6. I get the square root of x plus 4 equals 2. So those are the same operations you've used to solve equations in the past. Undo subtraction with addition, undo multiplication with division. I have the square root by itself, so what operation will undo square root? Squaring it, good. So we're going to square both sides. That will cancel out my square root. So I have x plus 4 equals 2 squared, which is 4. And then solve for x by subtracting the 4. And we get x equals 0. So we've done step 1, isolate the radical, and step 2, solve for x. We're left with step 3, which is check your answers. Okay, so here's my check. I'm going to do negative 6 square root 0 plus 4 minus 3 equals negative 15. So I just substituted the 0 for the x. 0 plus 4 is 4. What's the square root of 4? 2. So I have negative 6 times 2 minus 3 equals negative 15. Negative 6 times 2 is negative 12. And I finally get to negative 15 equals negative 15, so it worked. My check worked, which means I can box up this answer. This is my answer, x equals 0. All right. What questions do you have? Okay. So I want you to go back and do problems 1 and 2 and follow those steps. First, isolate your radical, then undo your radical, and then check your answer. All right, number 1, isolate the radical. Did you subtract 5 from both sides? Excellent. So subtracting 5, root x equals 4. And then to undo the square root, what did you do? Square it, good. So the inverse of square root is squaring. That will cancel out your square root. So you get x equals 4 squared, which is 16. Did anybody check your answer? Good. All right, so to check, I just put it for the x. Square root 16 plus 5 equals 9. Square root of 16 is 4. And I get 9 equals 9. So it checks out, and I can box up my answer here. Questions on 1? Okay. All right, and 2, how do I get rid of this 2 in front?
Divide.
Very good. So start by dividing by 2 on both sides. And I get cube root 5x plus 7 equals 3. How do we get rid of a cube root? Cube it. So the inverse of cube root is to cube. That will cancel. And so then you get 5x plus 7 equals 27. Solve that by subtracting and then dividing. All right, anybody else get x equals 4? Okay, let's just check it real quick. So to check, I have 2 cube root 5 times 4 plus 7 equals 6. That's going to make the cube root of 27. All right. Remember, cube root is a number times itself gives you 27. What is the cube root of 27? It's 3. You could do that on your calculator or you could do it in your head. So 2 times 3 equals 6, and we get to 6 equals 6, which checks out. And then go back and box up your answer. After doing the check, it's easy to lose track of where your answer was, so make sure you do that. Good morning. All right, raise your hand if you looked at problem 4 already. I'm not going to call on you. I'm just wondering who already started thinking about it. Nobody? I know one person did. All right, in problem 4, step 1 says to isolate the root, but it's already there, right? It's already isolated on the right side. So we're going to start by squaring both sides to get rid of the square root. So I square this side and I square this side. And on the right, the square root will cancel with the squared. So I get x squared equals 56 minus x. In problems 1, 2, and 3, after we got rid of our radical, we ended up with a linear equation, but this is not a linear equation. What is it? Quadratic, very good. All right, so quadratic equation because of the x squared. All right, so I see some of you still have computers open, but I did ask you to keep those computers closed. So remember, quadratic equations, they're just going to keep coming back. So to solve a quadratic equation, remember we need to make one side 0. So it'd be easy to think, oh, let's just subtract the x squared. However, it's much easier to solve it if we keep our x squared positive. So what we're going to do is we're going to add the x to both sides. And we're going to subtract the 56 from both sides to make the right side 0. So this side's going to become 0. On the left side, x squared and x are not like terms, so I don't really combine them. I just write x squared plus x, and then minus 56 equals 0. All right, talk to your neighbor real quick. How should I solve this? What should my strategy be? Talk to your neighbor, see what they think. I'm going to check in on my students real quick. All right, what's the strategy? Factor is an excellent strategy. You could have done quadratic formula, but this problem is a pretty easy one to factor. You're just looking for the numbers that multiply to negative 56 and add to 1. So negative 56 and add to 1 would be 8 and what? What kind of 7? Positive 8, right? And then a negative 7. Those are going to add to 1 and multiply to negative 56. And then when you set them equal to 0, you get their opposites, right? So we get x plus 8 equals 0. And you subtract 8 from both sides. And you get x equals negative 8. And then x minus 7 equals 0. And add 7 to both sides. And we get x equals 7. Now I think at least one group has already checked these answers. Who's checked the answers? You did? Did they both work?
Only one of them did.
Only one of them did? So we're going to check them and see which one works, okay? All right, so when you check them, use your original equation, not the one that you squared. So the original equation is x equals square root 56 minus x. So I'm going to check over here. I'm going to check x equals negative 8. Negative 8 equals square root of 56 minus negative 8. Now minus negative makes plus, right? So that's going to be 64. Negative 8 equals square root 64. Negative 8 equals 8. Is that true? Negative 8 equals 8? No. So that means that this answer will not get boxed up. It is extraneous. Okay, I'm going to check x equals 7. 7 equals square root 56 minus 7. 7 equals square root 49, and 7 equals 7. This one checks out. So this one I'm going to box up. This one's right. All right, rational exponents. Rational means ratio, so fraction, okay? Rational exponents act the same way as radicals. Remember that the denominator tells you what kind of radical you have. So the denominator being a 2 is a square root, and the denominator being a 3 down here is a cube root, okay? So you do something very similar. It's just that you have both a power and a root here, and you can get rid of both your power and the root at the same time by doing a reciprocal exponent. So take a moment to study this example problem over here, okay? With a reciprocal exponent. Yes?
I have a question on later problems. So when you're multiplying by a reciprocal exponent, does it only goes to the stuff that's in the parentheses, right?
So you're going to multiply this by the reciprocal exponent, and that's actually going to cancel the exponent out. And then the other side is going to use your reciprocal. You have to isolate the x plus 3 first.
Okay.
All right, so actually that brings up a good question. Let's actually try, of course, the hardest problem first, and then you can go back and do the other ones. Let's look at 7. So we're going to start by isolating the part that's in the parentheses, okay? The part that's being raised to the exponent. So we're going to get this by itself. So get rid of the plus 4. And then get rid of the times 2. And so I have x plus 3 in parentheses to the 4/3 equals 16. Now if you don't have a calculator, now is a good time to go grab one, because raising something to a fraction exponent in your head is actually very tricky. It is not the same as multiplying it by a fraction. You can multiply by a fraction in your head. The fraction exponent takes a little bit more analysis. Okay. We need to eliminate our rational exponent, and we're going to do that by using the reciprocal. So the reciprocal of 4/3 is 3/4. So we're going to raise this to the 3/4 power. And on this side, we're going to raise the 16 to the 3/4 power. Now, let's consider why we're doing this. When we do 4 times 3, we get 12. And when we do 3 times 4, we get 12. So our exponent is 12 over 12, which equals what? 1. All right, anything to the 1 power is itself. So essentially what we're doing is we are canceling out the exponent on this side. And we're putting the exponent of 3/4 on this side. All right, it might take me a minute to get my calculator up, but when you are doing this on your calculator, you're going to need to put parentheses around your exponent like this. So you're going to do 16 raised to the 3/4 and put that 3/4 in parentheses. I'm going to see if I can get my calculator up as quickly as possible, but you guys try to do that too. Okay, so on your calculator, if you haven't done it yet, type this 16. And then for the exponent, it's this one that's above the divide. So on the right side, go above divide. It's called caret. And that gives you that exponent. And now, my calculator is a little bit newer, so I don't actually need the parentheses, but it doesn't hurt. Yours will need the parentheses. And you're going to put in 3 divided by 4. All right, so the steps are the same on those older calculators. I know it looks different, but if you haven't typed anything yet, you're not really following along. I'm going to do it one more time. So I get 8, but I'm going to type it again. 16. Then you need this caret, which is above the divide. On the older calculators, it doesn't really go up. It just gives you that caret sign. Then you're going to do parentheses, 3/4. And then close your parentheses, and you get 8. Now remember, we're not doing 3/4 of 16. You guys know that 3/4 of 16 is not 8, right? What we did there was we did the 4th root of 16, which is 2, and then 2 to the 3rd power, which is 8. But your calculator did it all in one step. All right, so we got 8. So we got x plus 3 equals 8. Subtract 3 from both sides. We get x equals 5. Now, I want you to take a minute to go back and check your answer. Put the 5 back in here. And you can do the whole thing on your calculator in one step. You're going to do 2 parentheses 5 plus 3 raised to the 4/3 plus 4, and you should get 36. If you get 36, it checks out. Okay? So try that right now. 1 second. All right, so we are going to check. Let me see if I can pull this back up. Okay, so I need to type 2 parentheses 5 plus 3, close parentheses, raised, parentheses, 4/3, and then plus 4. I did get 36, so it checks out. We're good. It checks out. So x equals 5 is correct. All right. I want you to take a moment, go back and do 5 and 6. In problem 5, what fraction will we raise both sides to? Problem 5, what fraction should it be? 2/3. Good, because reciprocal. All right? And then use your calculator. Remember to put parentheses on the 2/3 and then do 6. And of course, do 8 if you finish 5 and 6. Okay, let me unfreeze my screen. And here we are. So for the 3/2, we use the reciprocal 2/3. And that's going to cancel out your exponents over here. So I get x minus 27 equals 64 raised to the 2/3. When you put that in your calculator, put parentheses on it. Okay? So let me go back to my calculator. And I'm doing 64 raised to the 2/3. That means cube root and then square. I get 16. So x minus 27 equals 16. Add the 27. X equals, you get 43? Yeah. And then we'll check it. So I'm doing 43 for my x minus 27 raised to the 3/2. Before it checks out. All right, so I'm going to go to the calculator. Parentheses, 4 minus, close parentheses, raised to the 3/2. And I do get 64, so 4 equals 64. And so I box up this answer. Do problem 6 as our last problem. It's on 5. Those of you who are that you're not going to have time to top, let me know if you can come after school. And if not, if school on Friday. We're going to have school Friday. I don't know if we're going to have school Thursday. Okay. We have to get rid of this 8. We have 1 to the 1/2, 5. To square both sides, that your calculator does not square, you put the negatives. So when I square this, the reciprocal of 1/2 is, so have to square -5 times -5 should give you 25. So these will cancel. 4x1 equals 25. Solve for x and divide.
Good morning, Seahawks. Today is Tuesday.
Guys, let's still check our answer, even though they're going to do
7 and then 5. That week have been released 2 5 of the United States and to the republic for which it stands, under God, indivisible, with liberty and justice for all. Please be seated for the moment of silence. Seahawks will image have a turn 52 cents.
this one. We get 25 to the 1/2. 8 equals 25 to the 1/2 is square root 5.